Hey everybody, this is part 2 of the acceleration video, and I split this into 2 parts because I really wanted to focus on the equation and the theory behind it, and in this one we're going to focus on how do we represent this graphically. You need to be able to read these graphs, not so much draw these ones, but read these ones. And so we're going to talk about this graph. It looks very similar to a distance versus or a position versus time graph, but now we're talking speed versus time, so we're showing something completely different. Speed is our dependent variable, time is our independent, so as time progresses my speed is going to change. Now remember, on a distance versus time graph, a flat line meant we were, or a flat slope, not a flat slope, a consistent slope meant we were at a constant speed. A flat line meant we were stopped. A speed versus time graph is different. Now we're showing a change in speed as the dependent versus time. So where is acceleration shown? Well, acceleration is any non-zero slope because our speed is increasing from this point to this point, right? So this is a non-zero slope. So anytime our slope is going up or going down, an increasing slope, a positive slope, means I'm increasing my velocity in the forward direction. A negative slope means I'm increasing in the reverse direction. Another way to think about this is deceleration, and we're going to talk about the nuance of that in class. So where's constant speed shown? That's the other good question. This is your flat line, because look, my speed at this spot is 50, my speed at this spot is also 50, so these are the zero slope segments, or the flat spots. So this is not constant acceleration, this is not constant speed. Flat lines do show us constant speed. All right, this is not stopped, so make sure you understand the difference. Pay attention to your labels. We can still calculate acceleration from this. So if I go back up, look at our equation. Remember, acceleration is our change in velocity, v final minus v initial, over a period of time. We can get that information by reading one of these graphs. So let's do a simple one, starting for letter A, right here. Our v initial is 0, our v final is 30, and our time is from 0 to 1, so this is 1 hour, right? We can take our information, our v final is 30 miles per hour, subtract it from 0 miles per hour, and divide that by 1 hour. We end up with 30 minus 0 is 30 divided by 1, so our acceleration is 30 miles per hour, and we can represent that as 30 miles per hour squared. Okay, so this would be our acceleration for that first line segment. I'm actually going to do a second one. So let's look at our acceleration for line C. So we're going to start right here. Actually, let's do this one in red so we can see it differently, see it visually differently. So I've got my first acceleration, or my first velocity here, and my final velocity there. So this one is going to be 50 miles per hour minus my initial, which is 30 miles per hour. And this is divided by our time. So we're going from 1.25 all the way up to 4. So this is by 3.75 hours. So when we subtract, we do 50 minus 30, gives me 20 miles per hour divided by 3.75 hours. And so when I grab a calculator, we do 20 divided by 3.75. And again, when you get these big long repeatings, give me one decimal place. So this acceleration is 5.3 miles per hour squared. So for every hour we watch, we increase by 5.3 miles per hour. So you can read these graphs. I'm going to have you do a negative one in class. So we're going to look like line G, for instance, right? What does that really mean in application? So we're going to talk about the different slopes, but I wanted to make sure I gave you some of that knowledge level stuff again on how to read one of these graphs. So if you have questions, you can leave it in the comments. Take a look at the first video. If you haven't watched that yet, you can click on the little button and it will jump you backwards. Otherwise, I'll see you in class.